All right, now I'm on page 312. Example 1 says write an equation for the word sentence. The word sentence is 6 fewer than a number is 46.33. So we know a few things. We have 6, we have fewer, which I know means minus, and a number, we can use n for a number. That's our variable, and then we have another number here, okay? So let n represent the unknown number. The phrase fewer than indicates subtraction. We already said that. Okay. So we want 6 fewer than a number. So we want a number, and then we want 6 fewer than that. Minus 6 is 46.33. Okay. Now, notice this error alert. Okay. Many times students want to, and I was guilty of this as well when I was in 6th grade. You want to go right in order. And sometimes that works. Sometimes that happens to work, okay? But just because it happens to work once doesn't mean it will always work. And what they want to do is say, oh, okay, 6 fewer, that's minus, n is number, equals is the word for equals, and then 46.33. Okay. Now I understand how sometimes if you're going through something quickly, that makes sense, right? Why isn't that right? Why can't I write 6 minus n equals 46.33? Well, if we read carefully, it says 6 fewer than a number. 6 fewer than a number, not 6 fewer than, or we're taking a number away from 6. We're not taking 6 away from a number, okay? I know it's kind of semantics there. It sounds like it's very wordy, and it is, but you have to read carefully. We're saying 6 fewer than this number. So we're taking 6 away from this number. We want 6 less than whatever this number is. So in order to take 6 away from this number, you have to put the number first, then take 6 away from it. That's very different than saying I have 6 and I'm taking some number away from 6. Okay? And then think about it. Okay? Logically, look at the whole problem as well. If I have 6 minus a number, how am I going to get 46.33, a larger number? Okay, it doesn't really make sense when you actually look at the whole problem. So once you've solved these, make sure you look at the whole problem, okay, to see if it makes sense. Okay. All right. B, 2/3 of the cost of the sweater is $18. So 2/3, I know, is the equal sign. Cost of the sweater, we'll say that's S. We don't know what the cost of the sweater is. So, okay, they told us what they want it to be C, the cost of the sweater. Let C represent the cost of the sweater in dollars. The word of indicates multiplication. So that of tells us we're dealing with multiplication. Okay, so 2/3 of cost of the sweater is 18. So this was one of those examples where it was nice and easy for us, right? It all came in order. 2/3 was first, 2/3 of, or of either, well, actually, we do want to use that of. Of is our multiplication. Cost of the sweater, C, is equals 18. It went right in order that time. But it won't always do that. And you want to be particularly cautious of the order of these numbers when you're dealing with subtraction and division, okay? Because we know the order matters a lot more when you're dealing with subtraction and division. When you're dealing with multiplication, 5 times 3 is the same thing as 3 times 5. But when you're dealing with subtraction, 5 minus 3 is not the same thing as 3 minus 5. Okay? Same thing with division. Okay? The order matters. So double check your order, like on example A. Double check your order when you're dealing with subtraction or division. Okay? It's going to mean a lot less on multiplication and addition. All right? But order definitely is going to matter big time on subtraction and division. So those are the problems you want to double check your answer. Okay? All right. Write 2-word sentences for the equation. A plus 15 equals 24. Okay. So the sum, addition means sum, of A, there's A, and 15 is the word for equal sign, 24. Okay. Or we could write it as 15 more than A equals 24. It's another way we could write it. Okay, over here, the quotient, because I'm dealing with a division problem. Answer to a division problem is a quotient. The quotient of R and 0.2 is the word for equals. Another way I could write it is R divided by 0.2 equals 40. So you can see there is some variation allowed in how you write out the word form of these equations. There is some variation allowed. As long as they mean the same thing, you haven't changed the meaning of the sentence, okay, of the number sentence. All right, same thing as if saying quickly get in the car or hurry up and get in the car. Use different words, but they both have the same meaning, okay? That's what you can think of with these examples. Use different words, but they have the same meaning, okay? All right, thanks for watching, and I will see you on the next one where we will start on page 313.